This week we've studied measures of center and measures of variation. So I'd like to take some data from our textbook and see if we could just have a conversation about those things. So on page 116, I'd like to look at problem number 8. The instructions in the text are: find the range, variance, and standard deviation for the given sample data. Include appropriate units. Then the author makes a note that the same data was used in section 3.1, where we were to find measures of center. We're going to do both jobs right now. Looking at problem 8, we're told that the data listed below are estimated incomes of students who graduated from the University of North Carolina, UNC, after majoring in geography. The data are based on graduates from the year 1984. And the income of basketball superstar Michael Jordan, who also was a geography student at the University of North Carolina and graduated in 1984. Then we're asked if his income, right here at the end, has any effect on the results. Well, I think it will, but our first job, I want to find all of the measures of center and all of the measures of variation we've talked about using this data set. So our first job would be to enter the data into our TI-83. So I'm going to hit the Stat button, go into the Edit menu, and I'd enter the data into list 1, which nicely, or fortunately, I've already done. So what I want to do now is compute the measures of center and measures of variation that we've studied. So I'm going to hit Stat, I'm going to go over to Calc. I'm going to choose one of our stats. Since my data is in list 1, I could just press enter, but I'm going to hit second 1, just to always remember to tell my calculator what list the data is in. I'm going to press enter, and then we can get started finding all of our measures of center and measures of variation. We've talked about 4 different measures of measures of center. We have talked about the mean, the median, the mode, and the mid-range. Well, the mean's given to us in the one of our stats menu. So I now know that the mean, or what we would typically or colloquially think of as an average, is $260,741. Our round-off rule would say to round this to 1 decimal place. I'm just going to go on and include that next one because we're dealing with money here, and I think rounding to the nearest whole cent makes sense. Next up, I want to write down the median, which is actually on the second screen here in one of our stats. So there it is. The mode, the most frequently occurring data point, well, if I look at this very small sample, I don't see anything that repeats, so there's not going to be a mode here. And then the mid-range is the maximum data value plus the minimum data value divided by 2. And so the largest data point is Michael Jordan's salary, and the lowest one's is $16,354. So let's do that calculation. 2.2 million plus 16,354. Now I need to divide that by 2. So the mid-range not a good estimate of center, I don't think, but that's what it comes out to for this data set. All right, well, let's think about these, and then the question, does Michael Jordan's salary affect these results? When I look at the rest of the data, I see that this one stands apart. The rest of these are in the high teens, thousands of dollars. So, 16 to just under $20,000 there, and then Michael Jordan's salary is way larger. Well, this measure of center is way larger than all but one of the data points, right? It's not a good measure of center. The mid-range is even worse. It's basically half of Michael Jordan's salary, and then it has nothing to do with the rest of the data set at all. Well, this is one of the things we talked about in class. The mean is affected by outliers. The mid-range is greatly affected by outliers. The median, though, that's a little more resistant to outliers. Actually, that's very resistant to outliers, and that's the best measure of center we have for this data set. I want to write down the measures of variation and talk about them, and then I want to come back to this and take Michael Jordan's salary out and see what happens to these measures of center then. But for now, let's pull back, or go back to the one var stats menu and write down our measures of variation. So I see a sample standard deviation here. S equals, and standard deviation is in dollars, they're in regular units, so let's see, 727,222 $89. That's a giant standard deviation, again in dollars, using units, always using units. All right, I need to square that to find the variance. And then to find the range, I'll have to do subtraction between the largest and smallest amounts. All right, so I'm going to square the standard deviation. So the variance here, giant value, in square dollars. Okay, let's see what's going on there. That is 5.3 billion square dollars. That's the variance. All right, the range. Range just comes in regular units. Ooh. Missing a 6 on the end. So 2,183,646. And now I'm asked to compute the coefficient of variation. That's where I take my standard deviation and I divide it by the mean and I express it as a percentage. Right now I can't read my own handwriting, so let's just go back in there and double check that, make sure that's a 4. And it's a 9, so it's almost off there. Let's now calculate that coefficient of variation. The coefficient of variation is 278.9%. Crazy amount of variation in this distribution. But again, Michael Jordan's salary throws off the mean. That's involved in the calculation of the standard deviation and the variance. And we're calculating an average deviation from center. And I think Michael Jordan's salary being so large is really throwing that off. And that's why we see such large values for all of our measures of variation. So let's take Michael's salary out and see what happens then. So I'm going to go back into my calculator, and I'm just going to go down to that last data value where Michael Jordan sits. I'm going to delete it. Now I'm going to redo all these calculations and see what happens. The mean is now $18,333.75, and that looks way more like the rest of the data. The median barely changed, and the only reason it changed is because I deleted a data point. It went from being a list with 8 things to a list with 7 things, but the median, pretty resistant to that change, didn't move a lot. Still no mode. And the mid-range is going to be very different this time. The largest thing on the data list is now 19,682. And so the mid-range is now 18,018. All of these now look like good measures of center when I'm imagining this data set without the one that doesn't belong. Well, let's look at the measures of variation. My standard deviation is now just $1,159.28. I need to square that to find the variance. All right, and I'm going to carry a few more decimal places this time. Well, maybe not because I can't see them now. Variance still comes in units of square dollars. The range, the largest thing minus the smallest thing. So the range, 19,682 minus 16,354. $3,328, a much smaller range of data. And now I want to write down the coefficient of variation. And I'm going to sneak that in over here, kind of borrowing some space from the measures of center size side of the board. So I'm going to take my standard deviation, I'm going to divide it by my mean. And I want to write that as a percentage. So now the coefficient of variation is a much more reasonable 6.3%. And so what I see is that without Michael Jordan's salary, there's actually not a whole lot of variation in that data set at all. His was throwing everything off because it was orders of magnitude larger than the rest of the data. And that can show you the dramatic effect one outlier can have on a data set.